Professor Reed stood at the front of the classroom, his weathered face betraying nothing of the amusement he felt as he observed the diverse group of alien students before him. As the only human professor at the Galactic Academy of Higher Learning, he had grown accustomed to the curious stares and whispered comments about his fragile human physiology. "Today," he announced, his voice carrying effortlessly across the lecture hall, "we begin our unit on evolutionary adaptations to extreme planetary conditions." The class perked up. This was, after all, one of the most anticipated subjects in comparative xenobiology. "We'll start with a case study," Reed continued, activating the holographic display. "My home planet, Earth." A ripple of polite interest passed through the class. Earth was classified as a Class 12 death world, known mainly for producing hardy, if somewhat primitive, beings who had only recently joined the Galactic Council. Trill, a blue-skinned Aquarian with delicate gill structures, raised a webbed hand. "Professor, no disrespect intended, but isn't Earth rather unremarkable? Besides its high gravity, of course." Several students nodded in agreement. The Galactic classification system ranked planets from 1 to 15 based on environmental hazards. Class 12 was certainly respectable, but not exceptional. "An excellent question," Reed smiled, displaying an image of Earth's varied landscapes. "Earth is unique not for any single environmental extreme, but rather for its incredible diversity of hostile conditions." He swiped through images of scorching deserts, frozen tundras, dense jungles, and stormy seas. Most species in this room evolved on planets with consistent environmental challenges. Your body's adapted to one primary threat. Reed looked directly at Trill. Your species adapted to underwater pressure and low oxygen levels, but would struggle in a desert. Trill's gills fluttered in acknowledgement. Humans, Reed continued, evolved on a planet that tried to kill us in hundreds of different ways. We faced extreme temperature variations, atmospheric pressure changes, toxic plants and animals, natural disasters, radiation, and diseases that constantly evolved against us. He pulled up a new holographic display showing human cellular structures. Our bodies are walking chemical factories, capable of adapting to almost any environment given enough time. Dax, a crystalline being from a low-gravity world, chimed in, "But Professor, humans aren't particularly strong or fast compared to other Death World species." "True," Reed acknowledged, "but our advantage isn't in specialized physical traits. It's our adaptability and endurance." He projected a new image showing humans engaged in various activities across extreme environments. "We can survive in environments from -50 to +50 degrees Celsius with minimal technology. We can go weeks without food, days without water, and unlike many species, we can recover from most injuries rather than simply dying." Murmurs rippled through the classroom. "For your first assignment," Reed said, calling their attention back, "I want each of you to research a specific Earth environment and analyze how humans adapted to survive in it. Consider not just biological adaptations, but technological and social innovations as well." As the students filed out after class, Trill lingered behind. "Professor," the Aquarian asked hesitantly, "is it true that humans used to hunt prey by simply following it until it collapsed from exhaustion?" Reed smiled. "Persistence hunting. Yes, some human cultures practiced it for thousands of years. We're not the fastest creatures, but we're remarkably difficult to exhaust." "Fascinating," Trill murmured, "and somewhat terrifying." "That's an appropriate reaction to most human adaptations," Reed replied with a slight chuckle. "We'll discuss more tomorrow. I think you'll find our immune system particularly interesting. It essentially wages microscopic wars against invaders constantly." As Trill departed, Professor Reed began preparing his notes for the next day's lecture. The students had only scratched the surface of humanity's Death World adaptations. Tomorrow, he would show them what it truly meant to evolve on a planet that never stopped trying to kill you. The next day, the classroom buzzed with excitement as students discussed their initial research into Earth's environments. Professor Reed entered, carrying what appeared to be a small container. Yesterday, he began, we discussed Earth's environmental diversity. Today we'll examine how this shaped human psychology and social structures. He placed the container on his desk. But first, a demonstration. I need a volunteer. Dax, the crystalline student, moved forward. I'll volunteer, Professor. Excellent. Please describe your homeworld's primary hazards. Crystallis has minimal environmental threats, Dax explained. Our main concern is harmonic resonance storms that could shatter our outer layers. Reed nodded. And how does your species respond to unexpected threats? We analyze, form consensus, and implement solutions gradually, Dax replied. A logical approach, Reed said. Now, observe. Without warning, Reed opened the container and something small and furry leaped out, landing on the desk. Several students gasped and recoiled. This, Reed said calmly, is a hamster, a completely harmless earth mammal. The tiny creature sniffed curiously at the edge of the desk, while Dax stood frozen in place, crystalline structure vibrating in alarm. Note your instinctive reactions, Reed continued. Most of you moved away from an unknown entity before assessing its threat level. This is remarkable. He gently returned the hamster to its container. Humans evolved alongside countless species that could kill us, from microscopic parasites to massive predators. This created what we call a threat detection system that's constantly active. Reed dimmed the lights and activated a brain scan hologram. Human brains devote significant resources to identifying potential dangers before conscious thought occurs. We call it intuition or gut feeling, an evolutionary advantage on a planet with countless ways to die. Mela, an empathic student with translucent skin, raised her hand. Professor, does this mean humans live in constant fear? Quite the opposite, Reed replied. We've evolved to thrive on stress and challenge. Humans become restless in safe, unchanging environments. He displayed a series of historical images. Throughout our history, we've deliberately sought out dangerous situations, climbing mountains, exploring oceans, venturing into space, all without biological necessity. That seems irrational, commented Grell, an insectoid student. From a survival standpoint, perhaps, Reed acknowledged. But it drove our rapid technological development and eventual space exploration. Humans don't just survive hardship, we're shaped by it. He brought up new images showing human settlements in hostile environments, underwater habitats, desert outposts, Arctic research stations. Our sociology developed around overcoming environmental threats through cooperation. Unlike species from stable worlds, we formed flexible social units that could rapidly adapt to new challenges. Reed highlighted statistical data on human crisis response. When faced with disasters, human communities typically display increased cohesion and altruism. We've evolved to become stronger under pressure. The students were silent, absorbing this information with varying degrees of discomfort. This psychological resilience extends to information processing, Reed continued. Humans can entertain contradictory ideas simultaneously, a necessary adaptation for a species that needed to constantly revise its understanding of an unpredictable environment. He displayed footage of human children at play, engaging in what appeared to be mock combat. Even our recreation simulates danger. We call it fun, the pleasurable sensation derived from navigating challenging situations. Trill's gills fluttered anxiously. Professor, these traits sound more like a predator species than a sentient civilization. An astute observation, Reed nodded. Humans evolved as omnivores with predator tendencies. We're one of few species who systematically hunted creatures significantly larger and more dangerous than ourselves. He closed the presentation with an image of Earth as seen from space, a fragile blue marble. For tomorrow, Reed said, I'd like you to consider this. How might a species shaped by constant, diverse threats approach interstellar diplomacy differently than those evolved in stable environments? Class dismissed. As the students filed out, Many cast uneasy glances back at the professor, seeing him in a new light, not as the mild academic they'd assumed, but as something more complex and potentially dangerous. The lecture hall was unusually quiet the next day. Professor Reed noted how the students maintained slightly greater distance from him than before. Good, they were beginning to understand. Today, he announced, we discuss human biological adaptations, focusing on our damage resistance and recovery capabilities. He activated the medical scanner, allowing it to project a holographic model of his own body. Humans evolved on a high-gravity world with substantial atmospheric pressure. Our skeletal structure reflects this. The hologram highlighted his bones. Our bones continuously rebuild themselves in response to stress. Break a human bone, and it often heals stronger at the fracture point. Grell, the insectoid student, clicked his mandibles thoughtfully. Like adaptive architecture. Fascinating. Precisely. Reed nodded. But our true evolutionary marvel is our immune system. The hologram zoomed in, showing microscopic cellular activity. Unlike most sentient species who evolved in relatively sterile environments, Earth teems with microscopic threats. Bacteria, viruses, parasites, all constantly evolving against us. The hologram displayed white blood cells engulfing pathogens. Our immune system doesn't just fight invaders, it remembers them. It learns and adapts throughout our lifetime, becoming more efficient against repeatedly encountered threats. Several students shifted uncomfortably as the implications became clear. This adaptive immune system gives humans remarkable disease resistance compared to most galactic species, though it comes with drawbacks. Reed smiled slightly. Our immune systems sometimes overreact, causing allergies or autoimmune disorders. The price of vigilance. He tapped his display, changing the hologram to show a human with various injuries. Now, regarding physical trauma, humans possess extraordinary healing capabilities. We can recover from injuries that would be fatal to many species. The display showed accelerated healing of wounds, broken bones, and internal injuries. We clot rapidly to prevent blood loss, then rebuild damaged tissue through a complex cascade of cellular processes. Given time and proper care, humans can recover from massive trauma. Mela raised her hand. Professor, I've read that humans sometimes survive losing entire limbs. Is this accurate? Indeed, Reed confirmed. While we can't regenerate completely like some species, we can survive the loss of limbs, portions of vital organs, and even parts of our brain while retaining functionality. The class murmured in disbelief. Our native bacteria further protect us, Reed continued. Human bodies host trillions of microorganisms that help us digest food, produce vitamins, and defend against harmful pathogens. We're walking ecosystems. He paused, observing their reactions before proceeding. Perhaps most remarkable is our nervous system's adaptability. The hologram highlighted the human brain and spinal cord. Human brains can reroute neural pathways around damaged areas. With training, a human who loses function in one body part can often transfer that capability elsewhere. Trill's gills fluttered rapidly. Professor, these adaptations suggest humans evolved expecting to be regularly damaged. What kind of planet necessitates such resilience? A planet where standing still means death, Reed answered simply. Earth's evolutionary pressures never relented. Species that couldn't adapt died. He switched the display to show Earth's history of mass extinctions. 5 major extinction events wiped out most life on Earth before humans evolved. Our distant ancestors survived them all, adapting and evolving through catastrophes that obliterated countless other species. Reed turned off the hologram, facing the class directly. Consider this. Humanity's biological adaptations reflect a species that expects to be injured, infected, and challenged continuously, and has evolved to endure regardless. Dax's crystalline form shimmered with agitation. Professor, if humans are this resilient individually, what does it mean for human collective response to threats? Reed's expression grew serious. An excellent question for tomorrow's lecture on human warfare and crisis response. For now, consider this. Species that evolved on stable worlds tend to develop specialized adaptations for specific environments. Humans developed adaptability itself as our specialization. He glanced at the time display. For tomorrow, I'd like each of you to research historical examples of human survival against environmental catastrophes. Class dismissed. As the students gathered their materials, their movements were more deliberate, their glances more wary. They were beginning to understand what it meant to evolve on a death world, and what kind of species such evolution produced. The following day, Professor Reed entered the classroom wearing what appeared to be simple cloth garments. This departure from his usual academic attire immediately caught the students' attention. Today, he began, we examine human technological adaptations. Unlike biological evolution, technological adaptation occurs rapidly, allowing humans to survive environments far beyond our natural tolerances. He gestured to his clothing. I'm wearing cotton and wool, plant fibers and animal hair woven into protective coverings. This simple technology dates back thousands of years, yet it demonstrates a key principle. Humans modify our surroundings rather than waiting for evolution to modify us. Reed tapped his display, showing primitive human dwellings across different environments. Igloos in Arctic regions, nomadic tents in deserts, stilted houses in flood zones. Early humans expanded across Earth, not by evolving specialized bodies for each environment, but by creating technological extensions of ourselves. We call this the Swiss Army knife approach, remaining generalists while developing specialized tools. Grell raised a limb. Professor, wouldn't specialized evolutionary adaptations be more efficient? More efficient for stable conditions, Reed corrected. But Earth's environments change constantly. Species with highly specialized adaptations risk extinction when conditions shift. Human technological adaptation can occur within a single generation. The display shifted to show modern environmental suits, deep-sea diving equipment, space suits, hazardous material protection. With basic technology, humans can temporarily survive almost anywhere. Vacuum, underwater, extreme radiation, toxic atmospheres. We've walked on our moon wearing nothing but specialized clothing and portable air supplies. Several students exchanged incredulous glances. But the truly remarkable aspect is how we develop these technologies. Reed continued, humans possess an adaptation I call predictive problem solving. We create solutions for problems we haven't yet encountered. He displayed historical images of early aviation and spaceflight experiments. We built machines to fly before we needed to fly. We designed spacecraft before we required space travel. We created vaccines for diseases that hadn't yet emerged. Trill's voice wavered slightly. You're describing technological development as an extension of your evolutionary adaptability. Precisely, Reed nodded. And it accelerates with each generation. Consider our communication technologies. The display showed the progression from written language to digital communications. We developed methods to preserve and transmit knowledge across time and space, allowing each generation to build upon previous innovations rather than starting anew. This created exponential technological growth. Reed paused, observing their reactions before continuing. But perhaps most significant is our approach to failure. He displayed images of various technological disasters, crashed experimental aircraft, failed rocket launches, collapsed bridges. Humans expect and plan for failure. We build redundancies into critical systems. We analyze catastrophes to prevent recurrence. We simulate disasters to prepare responses. His voice grew solemn. Every major human technological advance is built upon countless failures, often fatal ones. Mella's translucent skin pulsed with emotion. You sacrifice individuals for collective progress. Not intentionally, Reed clarified. But we accept calculated risks. Humans who test boundaries often face consequences, yet their efforts expand our collective capabilities. He smiled grimly. We have a saying. We stand on the shoulders of giants. Many of those giants did not survive their contributions. The display shifted to modern human environments, underwater habitats, space stations, terraforming projects. Today, humans live in environments that would kill unprotected individuals within minutes. We've expanded our habitable range far beyond our biological capabilities through technological adaptation. Reed shut down the display, regarding the class seriously. For tomorrow's discussion on interspecies implications, consider this. Most galactic species evolved on worlds with consistent challenges, developing specialized biological adaptations over millions of years. Humans faced constantly changing threats and developed rapid technological adaptation instead. When these approaches intersect in galactic society, misunderstandings inevitably arise. He glanced at the time. Your assignment: analyze how human technological adaptation might appear from your species' evolutionary perspective. Class dismissed. As the students filed out, their conversations were more subdued than usual. Several cast backward glances at their professor, reassessing everything they thought they knew about the deceptively ordinary-looking human teaching them about life's adaptations. When the students arrived for the 5th session, they found the classroom transformed. The lights were dimmed, and images of Earth's history of conflict flickered across the display screens. Professor Reed stood silently until everyone was seated. Today, he said quietly, we discuss humanity's most controversial adaptation, our capacity for organized violence. A tense silence fell over the room. Humans evolved as social predators, Reed explained, combining pack hunting tactics with tool use. This created unique selection pressures. We needed to cooperate within groups while competing against rival groups. The display showed primitive human hunting parties, then early tribal conflicts. Most sentient species evolved either pure cooperation or individualistic competition. Humans developed situational altruism, extreme cooperation within our group and potential aggression toward outsiders. Dax's crystalline structure dimmed slightly. You evolved to fight yourselves. In a manner of speaking, Reed acknowledged, intergroup conflict drove rapid innovation in both technology and social organization. Those who coordinated better survived. The display shifted to show increasingly complex human warfare through history. But the truly unique adaptation is how conflict shaped human cooperation. Under threat, humans form remarkably cohesive units, temporarily suspending individual self-interest for group survival. Reed displayed data comparing human response times to various stimuli. A human under threat makes decisions approximately 3 times faster than in normal conditions. Adrenaline, a hormone that floods our system during danger, enhances strength, speed, and pain tolerance temporarily. Several students shifted uncomfortably. More significantly, Reed continued, conflict accelerated our technological development exponentially. The display showed military innovations that later transformed civilian life. Aircraft, nuclear energy, medical advances, the internet. Many of humanity's greatest scientific leaps occurred during periods of intense competition or conflict. Our space program emerged directly from missile technology. Trill's gills fluttered anxiously. Professor, this suggests humans become more dangerous when threatened. Accurate. Reed nodded, but incomplete. The same adaptations that make us formidable opponents also make us valuable allies. He switched the display to show international disaster response teams, space rescue missions, and medical researchers fighting pandemics. The same traits that evolved for conflict, rapid response to threats, resource mobilization, innovation under pressure, group cohesion, serve equally well for collective problem-solving. Reed paused, allowing them to process this information. Consider how humans respond to natural disasters. We rush toward danger to save strangers. We donate resources to people we'll never meet. This isn't purely altruistic. It's an adaptive strategy for a species that survived by group success. Mella's skin pulsed with emotion. You're describing a species adapted for both war and rescue, Professor. Isn't that contradictory? Not from an evolutionary perspective, Reed explained. Both scenarios involve high-stress crisis management. The same adaptations serve both purposes. He displayed a timeline of human conflicts alongside scientific breakthroughs. Here's what many species find difficult to comprehend. Humans don't just survive crisis. We often thrive in it. Our problem-solving accelerates under pressure. Our social bonds strengthen against common threats. Grill clicked his mandibles thoughtfully. This explains the paradoxical human behaviors in the historical records. Extreme violence alongside extreme altruism. Indeed, Reed nodded, and it shapes our approach to galactic relations. Humans instinctively form alliances against perceived common threats. We extend our in-group boundaries to include allied species. He looked around the classroom solemnly. When humans say we consider you allies, it means more than diplomatic pleasantries. It means we've psychologically reclassified you as part of our extended tribe, those we would defend rather than compete against. The classroom remained silent as this implication settled. For tomorrow's final lecture, Reed said, we'll discuss the practical implications of these adaptations for interspecies relations. Your assignment is to analyze potential misunderstandings that might arise between your species and humans based on our differing evolutionary psychology. As the students departed, their usual chatter was notably absent. They moved with new awareness, occasionally glancing back at their human professor, a being whose species had been shaped by conflict in ways they were only beginning to comprehend. The students entered quietly for the sixth session, many having spent the night researching human history with newfound perspective. Professor Reed noted their subdued demeanor with approval. They were finally beginning to understand. Today, he began, we explore humanity's most powerful adaptation, our capacity for abstract thought and knowledge transfer. He displayed a complex mathematical equation alongside primitive cave paintings. Humans evolved in environments where threats constantly changed. Rather than developing specialized responses to specific dangers, we developed pattern recognition and abstract reasoning. Reed highlighted the progression from simple symbols to complex written language. Most species communicate concrete information, warnings, mating availability, resource locations. Humans develop the ability to communicate abstract concepts, hypothetical scenarios, and accumulated knowledge. He displayed historical texts spanning thousands of years. Through written language, we achieved something remarkable. We conquered time. Knowledge no longer died with individuals. Each generation built upon previous understanding rather than rediscovering it. Trill raised a webbed hand. Professor, many species have knowledge transfer mechanisms. Indeed, Reed nodded, but human knowledge transfer has unique properties. We don't simply pass down confirmed information. We transmit theories, questions, and methodologies for discovering new knowledge. The display shifted to show scientific models evolving through history. Humans developed a process called the scientific method. Systematic observation, measurement, experimentation, and modification of hypotheses. This approach accelerated our understanding exponentially. Reed highlighted key scientific revolutions throughout human history. What truly distinguishes humans is our capacity to question our own understanding. We continuously revise our knowledge rather than merely accumulating it. Dax's crystalline structure pulsed with interest. This suggests humans evolved to expect their understanding to be incomplete or incorrect. Precisely, Reed confirmed. On a planet with constantly changing threats, rigid thinking meant death. Adaptable thinking, questioning assumptions and revising approaches, meant survival. He displayed images of human education systems. We institutionalized this process. Young humans are deliberately exposed to problems requiring creative solutions. We call this education. But it's really evolutionary preparation, training flexible problem solving rather than instilling fixed responses. Reed paused, observing their reactions. But perhaps our most remarkable cognitive adaptation is imagination, the ability to simulate scenarios we've never experienced. The display showed artistic works spanning human history, from cave paintings to immersive virtual environments. Humans can mentally model potential futures, simulate outcomes of different choices, and prepare for situations we've never encountered. This allowed our ancestors to anticipate dangers rather than merely reacting to them. Mella's translucent skin rippled. That explains human artistic expression. It's training for imaginative problem-solving. Partly. Reed agreed. Art also serves as emotional processing, another adaptation to stress. Humans transform trauma into narrative, finding meaning in suffering. He switched the display to show human collaborative enterprises, research teams, space missions, global engineering projects. Our cognitive adaptations culminate in collaborative problem-solving. Humans pool intellectual resources, combining specialized knowledge to address complex challenges. Reed highlighted examples of rapid human innovation during crises, vaccine development during pandemics, engineering solutions during disasters. When facing existential threats, human cognitive capabilities often peak. We call this necessity is the mother of invention. Our problem-solving accelerates under pressure. Grell clicked his mandibles. Professor, these adaptations suggest humans would approach interspecies relations differently than most galactic societies. Indeed. Reed nodded. Humans naturally form problem-solving collectives. We instinctively seek diverse perspectives when facing complex challenges. This extends to interspecies relations. We value cognitive diversity. He displayed footage of the first interspecies scientific collaborations. When humans joined the Galactic Council, many species expected us to be territorial or hierarchical. Instead, we eagerly sought collaborative opportunities, recognizing that different evolutionary paths created complementary cognitive approaches. Reed paused, allowing them to process this information. For our final session tomorrow, we'll discuss practical applications of this understanding for your future interactions with humans. Your assignment: identify one human cognitive adaptation that most complements your species' approach to problem solving. As the students prepared to leave, their earlier wariness had transformed into thoughtful consideration. They were beginning to see humans not as primitive deathworlders, but as beings whose harsh evolutionary path had created unexpected capabilities. For the final session, Professor Reed arrived early, arranging the classroom in a circle rather than the usual hierarchical rows. As students entered, he greeted each individually, noting how differently they regarded him now compared to the beginning of the week. When everyone was seated, Reed remained standing, surveying the class. Throughout this week, he began, we've examined how Earth's status as a death world shaped human evolution. Today, we'll discuss what this means for your future interactions with humans in galactic society. He activated a holographic display showing human-alien collaboration teams across the galaxy. The first principle to understand is that humans don't perceive ourselves as deathworlders. Earth's conditions are our baseline normal. This creates fundamental perceptual differences. Reed displayed data comparing risk assessment across species. Humans consistently underestimate environmental dangers while overestimating social threats. We'll happily explore uncharted planets, but grow anxious about making cultural mistakes at diplomatic functions. This elicited knowing chuckles from several students. The second principle: humans expect and require challenge for psychological well-being. Reed displayed brain scans showing human responses to various stimuli. Environments that other species find optimally comfortable often leave humans restless and depressed. We evolved requiring some level of stress. Trill raised a webbed hand. This explains why human recreation often involves artificial danger. Exactly. Reed nodded. Activities other species consider survival scenarios. Climbing mountains, navigating rapids, exploring caves. Humans pursue for enjoyment. He shifted the display to show various human-alien collaborative projects. The third principle: humans excel as crisis specialists. In stable situations, many species outperform us in efficiency and precision. But in rapidly changing circumstances requiring adaptation and innovation, humans often demonstrate remarkable capabilities. Mella's translucent skin pulsed with understanding. So in interspecies teams, humans function best handling unexpected developments. Precisely, Reed confirmed. The interruptions and complications that frustrate many species are exactly where humans demonstrate their evolutionary advantages. He displayed statistics on interspecies scientific collaborations. Fourth principle: humans process information differently. We excel at identifying patterns across seemingly unrelated domains, making intuitive leaps, and questioning established understanding. In research teams, humans often connect disparate concepts in unexpected ways. Dax's crystalline structure brightened. This explains why human scientists sometimes make breakthroughs by violating methodological conventions. Indeed, Reed smiled. What appears as chaotic thinking to some species is actually our adaptive cognitive style. We evolved hunting prey that constantly developed new evasion strategies, requiring us to continually revise our approach. The display shifted to show diplomatic interactions between humans and various species. Final principle: humans form attachments across species boundaries. Our tribal psychology is remarkably flexible. We readily extend our concept of us to include other species. Grill clicked his mandibles thoughtfully. This contradicts reports of human aggression during early contact periods. Not at all, Reed explained. Humans initially assess all unknowns as potential threats, and evolutionary adaptation. But once we categorize another being as an ally, that same protective instinct extends to them. Many species find the intensity of human loyalty disconcerting. He deactivated the display, regarding the class seriously. You're among the first generation being educated about humanity's evolutionary psychology. This understanding will serve you well in future collaborations. Reed smiled, a gesture that no longer seemed merely polite, but revealed a predator's awareness. Remember that humans don't just survive hardship. We're shaped by it. Challenge us, and we typically grow stronger. The comfortable environments that benefit many species often cause humans to deteriorate both physically and mentally. He looked around the circle, meeting each student's gaze. As you encounter humans throughout your careers, remember this: we may seem contradictory, simultaneously aggressive and altruistic, competitive and collaborative, chaotic and methodical. These aren't contradictions, but adaptations to a planet that never allowed specialization. Reed gestured to the galaxy map displayed on the wall, countless worlds marked with the colors of different species. The galaxy is entering an unprecedented era of interspecies collaboration. Each of us brings evolutionary adaptations suited to our homeworlds. Humanity's contribution is adaptability itself, born from surviving a planet that tried to kill us in 1,000 different ways. He sat down, joining their circle as an equal rather than standing as an authority. Any final questions before we conclude? Trill hesitated, then asked, Professor, given humanity's death world adaptations, do you think other species should fear humans? Reed considered this carefully before answering. Respect would be more appropriate than fear. Understand that humans instinctively classify others as either allies or threats, with very different responses to each. A human who considers you an ally will likely risk their life to protect you, not from logical calculation, but from deep evolutionary programming. His expression grew serious. But yes, a human who perceives your actions as threatening their group will access survival adaptations honed across millions of years on a death world. In that specific context, some caution would be warranted. The classroom fell silent as the implications settled. Remember, Reed concluded with a warm smile that somehow no longer seemed entirely harmless. The same evolutionary history that makes humans potentially dangerous also makes us uniquely valuable allies in a crisis. The question isn't whether humans are dangerous. It's whether you'd rather have us standing beside you or against you when facing the unknown. As the class session ended and the students filed out, many lingered to thank Professor Reed personally. They left not just with academic knowledge, but with a profound new understanding of the death world species that had recently joined galactic society. and what it might mean for their shared future among the stars.